Example 4. Suppose that in the simple circuit of figure 4, the resistance of 12 ohms and the inductance is 4 big H henries. If a battery gives a constant voltage of 60 volts and the switch is closed when t equals 0, so the current starts with big I of 0 equals 0. And A, I of big I of t, and B, the current after 1 second, and C, the limiting value of the current. Solution: if we put big L equals 4, big R equals 12, and big E of t equals 60 in equation 7, we obtain the initial value problem. 4 d big I over dt plus 12 big I equals 60 big I of 0 equals 0, or d big I over dt plus 3 big I equals 15 big I of 0 equals 0. Multiplying by the integrating factor e to the power, the integral of 3 dt equals e to the power 3t. We get e to the power 3t d big I over dt plus 3e to the power 3t times big I equals 15 e to the power 3t. D over dt open e to the power 3t times big I close equals 15e to the power 3t. E to the power 3t times big I equals the integral of 15 times e to the power 3t dt equals 5e to the power 3t plus big C. Big I of t equals 5 plus big C times e to the power negative 3t. So big I of 0 equals 0. We have 5 plus big C equals 0. So big C equals negative 5, and big I of t equals 5 times open 1 minus e to the power negative 3t close. B. After 1 second, the current is big I of 1 equals 5 open 1 minus e to the power negative 3 close is approximately 4.75 amperes. Big A. C. The limiting value of the current is given by the limit as t approaches infinity of big I of t equals the limit as t approaches infinity of 5 open 1 minus e to the power negative 3t close equals 5 minus the limit 5 minus, that equals 5 minus 5, the limit as t approaches infinity of e to the power negative 3t equals 5 minus 0 equals 5. See the sidebar. The differential equation in example 4 is both linear and separable, so an alternative method is to solve it as a separable equation. Example 9.3.4. If we replace the battery of a generator, if we replace the battery by a generator, however, we get an equation that is linear but not separable. Example 5. Figure 5 shows how the current in example 4 approaches its limiting value. See figure 5, y equals 5. Example 5. Suppose that the resistance and inductance remain as in example 4, but instead of the battery we use a generator that produces a variable voltage of big E to big E of t equals 60 sine 30 t volts. Find big I of t. A solution: This time the differential equation becomes 4 times d big I over dt plus 12 big I equals 60 times sine 30t, or d big I over dt plus 3 big I equals 15 sine 30t. The same integrating factor e to the power 3t gives d over dt open e to the power 3t times big I close equals, restarting this line, the same integrating factor e to the power 3t gives d over dt open e to the power 3t big I close equals e to the power 3t times d big I over dt plus 3 times e to the power 3t times big I equals 15 times e to the power 3t sine 30t. Using formula 98 in the table of integrals, we have e to the power 3t times big I equals the integral of 15 times e to the power 3t sine 30t dt equals 15 times e to the power 3t over 909 open 3 sine 30t minus 30 cosine 30t close plus big C big I equals 5 over 101 times open sine 30 times t minus 10 cosine 30t close plus big C times e to the power negative 3t. Since big I of 0 equals 0, we get negative 50 over 101 plus big C equals 0. So big I of t equals 5 over 101 times open sine 30t minus 10 cosine 30t close plus 50 over 101 times e to the power negative 3t. Forgive me if I got distracted.